Hey Math 121 class, here is your video of the week number 5. Now on the final exam last semester, my online class tended to struggle with these basic graph shapes and how you shift them around. So here are the main graphs that you just need to know how they look and basically how to draw them. We have the basic y equals x graph, that's this 45-degree line here. We have x squared, which is a parabola. We have x cubed, which looks something like that. This down here is the absolute value of x. And here is the square root of x. You'll notice that the domain of the square root of x is restricted to just the positive x values because you can't plug negative x values into a square root. Now let's start with a couple of basic shifts. If I take any of these graphs and I say subtract 1 from the graph, I'm subtracting 1 from the end of the function. What that does is it shifts that whole graph down 1 unit. So that is the absolute value of x minus 1 graph right there. If instead of subtracting 1, say I added 1, or let's even go and add 2, that would shift the graph up as many units. So you can see right away my amazing artistic abilities, my apologies. The point is, if you add or subtract the number to the end of the function, that shifts the graph up or down that many units. Pretty easy. Now with any of these graphs, if you replaced x with say x minus 2, in this example that would look like this. We've just replaced x with x minus 2. What that does is it shifts the graph to the right by 2 units. If you wanted to shift a graph to the left, let's say 3 units, you would just replace x with an x plus 3. And that graph would look something like that. Okay, so the moral of the story here is if you want to shift the graph to the left or to the right, you just replace x with x plus however much you want to shift to the left, or x minus however much you want to shift to the right. Now, I will erase some of these pink graphs in a minute to kind of clean things up. But first, let's talk about how you stretch a graph vertically. If I were to say look at a graph of 2x cubed instead of just x cubed, what that 2 multiplying out in front of the function does is it actually stretches the graph vertically. To be more precise, what that 2 does is it multiplies every single y value on the red graph by 2, which has the effect of stretching this thing out vertically. Now we can also shrink a graph vertically, and the way to do that is you multiply whatever your graph is by a number that's less than 1. Let's say a 1/3. If I wanted to see what 1/3 x cubed looked like compared to this x cubed graph I have, it would look kind of like you squished it vertically. It looks a little bit shorter in the vertical direction. So while I call these first 2 examples shifting, we're shifting up and down here and we're shifting left and right here, I typically call this last example stretching or squishing. This is a vertical stretch and a squish, which you get by just multiplying the outside of a function by some number. Now while you can stretch and squish things vertically, you can also do it horizontally. So if I replaced x with say 3x, and I wanted to see what that graph looked like, replacing x in any function with some multiple of x is going to have the effect of what I call a horizontal squish. So we're taking all of these x values and we're squishing them in. Now if we wanted to stretch something outwards horizontally, what we could do is replace x with some fraction of x. We'll just say maybe 1/2 x in this example. So you'll notice we just took our basic x squared and we just replaced x with 1/2 x. We still keep the basic shape of the graph, but this creates a horizontal stretching. And obviously you can read about all of these shifts and stretches and squishes in more detail in your book. I just wanted to give you a basic idea of what's going on in this video. Now what I'm going to do is I'm going to erase all of this pink stuff. So if you want to take a longer look at it, just hit pause on your browser. Here we go. And now I just want to briefly mention reflections. If you take any function and you multiply the outside of the function by a negative number, the impact of that negative number is going to be to reflect that graph over the x-axis. So if x squared looks like this, then negative x squared looks like that. One more example, if the absolute value of x looks like this, then the negative absolute value of x will look something like that. We call that a reflection over the x-axis. Now if instead of putting that negative outside in the front of the function, if instead we just replaced x with negative x, say square root of negative x, what happens is you actually get a reflection over the y-axis. Again, if we replaced x with a negative x in any of these functions, we would get a reflection of the graph over the y-axis. And you'll notice that if you replace x with negative x to reflect across the y-axis, a couple of these graphs are not going to look any different at all, namely x squared and the absolute value of x. We reflect either one of these two over the y-axis, and the graph looks exactly the same. Okay, so those are the very, very basics of graphing and shifting. Now keep in mind that any of these shifts, these stretches, these squishes, and these reflections that I talked about in the last few minutes, they can all be combined with each other. I'll just show you one really quick example. If I wanted to take the graph of x squared and reflect it over the x-axis and stretch it vertically, I could do that. The reflection over the x-axis would come from a negative sign, and a vertical stretch would come from multiplying it by some number bigger than 1. And those two shifts combined would give us a vertically stretched graph that is also reflected over the x-axis. Okay, so that was just an introduction for you. It went kind of fast, so feel free to watch it more than once or hit pause in the middle of the video. You'll have several homework problems about these types of graphs and shifts. So let me know if you have any questions, and I'll see you in the next one.